Hey, how's it going? Welcome back to the Wolf Pack. My name is Key, and half of my body is missing because apparently I have a lot of green shirts and I chose to wear one today, and I'm not taking it off. But that's neither here nor there. Uh, Welcome back to the stream. If you're here, then I want to thank you for being here, and hopefully you got something to work on. And if not, you can work on this with me. Okay, we can do this together. um, Right now, however, the chat feature seems to be broken, and I'm not quite sure how to fix it. So I'll check it and probably try to get it back up, like maybe during the break or the intermission, so have you. But until then, it's gonna be a little weird. Okay, so I'm gonna check that. I'm gonna try to get that fixed, but we should just move on because I got some housekeeping before we get into this. Okay, so the first things first. Let me go ahead and share my screen while I'm at it. So thank you for coming back. If you like this series where I'm working on Boot.Dev with GoLang, then I know you're going to love checking out my GitHub because if you just look right here, up in this area, I have all these GoLang resources, and these are just projects that I've worked on. And here's the thing: this is what's really going to sell it to you. I know this is going. I know you're gonna love this. I know you're gonna like it. In my repos, I make sure and I take extra care to write quality comments. And in all of my repos, you're going to find comments that I wrote, okay? If Nicki Minaj says she, was on it, then you know Nicki Minaj wrote it. Something like that, okay? So I did all of this. And when I did all of this, I was kind of making this stuff in the sense like I want to make repos and projects that are well commented and coded. And maybe it's not like the best, solutions to certain problems and stuff, but I try to write code you can understand. That's my number one goal. Okay. And what's nice about that is if you're someone who's learning Golang or who's even just interested or who wants to just be able to take a casual peruse through some Golang code and understand what it's doing, then this right here, this is for you. This is for you right there. Yes, you. Okay, so I'm being like super aggressive. I'm like, ah. But I'm really excited about this because I never really thought about the idea of like kind of advertising these as things that other people can look at. I really made them for myself, but I just happen to be a huge nerd. I happen to be a person who just really likes to just dig in and like I think I like the process of understanding code more than maybe I like building things. I don't know. That's probably a weird thing. I don't know. Am I the only one? In fact, if you're not the only one, if I'm not the only one and you feel the same way, which I hope is at least one other person, then go ahead and let me know in the comments because I would love to like feel supported and feel like not alone. But in the meantime, these repos, these ones right here, these are something that I highly encourage you to check out because if you're struggling at all with like understanding Golang, or if you're coming from like another language like JavaScript, then I think that you'll find these resources very helpful in your process of like kind of getting into like your second language. Does that make sense? So, if you're watching this video and you have any interest in Golang, or if this is something that you're interested in adopting for a second language, or maybe you're just kind of looking for something that you can compare to a language you already know, you will not find a better resource than what I've created for you right here in terms of actual working projects that have code that is well written and well commented by a human being. I'm a human being. Okay. So that being said, here's the caveat. I do use the AI occasionally to help me in the building of these things, more now than I used to be completely honest. However, I always try to make it a point when I do write code to actively engage my active recall. Does that make sense? Because the active recall, that's the thing that's going to help you learn. And this process of writing the comments to understand what these things are doing, that's where a lot of the learning and growth is coming from. Okay, so reading code is just as valuable as writing it. In fact, there are a lot of people out there who could write awesome code, but struggle to read it. if you can read code, what you're doing is you're improving your ability to think logically with what computers can do. And that's transferable. So this is a great place to start. And maybe it can be inspiring for someone out there because if you are working on little side projects, if you're working on spikes, if you're doing little explorations to test out and play with different types of things and whatnot, which I hope you are, then this is a great example of what that can look like for you. So feel free to take what I've done here, to use it, to put it down, flip it, and reverse it. Like, the L's that Missy Elliott had said one time in that song from when I was a teenager. Okay? You know the one. Do all of that, and this is for you. And I will continue to work on things like this. In fact, any language that I work on, or anything that I do in this stream here, is probably going to end up here. So go ahead and not only use this stuff, but also go ahead and give me a follow if you're on GitHub as well. And I will also follow you back because I want to connect, okay? So that was my first housekeeping. And then I also want to show you something else. I got a little something extra, a little extra seasoning just to kind of, make the day a little brighter. So if you go to your browser of choice, then you go to primitive.com like that. If this doesn't work, I'll be so embarrassed. Why is this going so slow? Oh, I'm sorry. I gotta fix it. But this is what you can do. You go www dot, okay? We're gonna have this fixed up soon enough. Oh, Lord Jesus, it's a fire. Okay, you know what? Ignore that. Go to linktree.com/primitive. I know that's gonna work. I'll get the domain thing figured out a little later. You don't have to accept cookies, but this is what I got for you. Okay, so I'm slowly kind of putting pieces together. As you can see, it's rough and raggedy, but it's gonna come together. I promise you that. Okay, so my whole thing is like I used to feel like I had to wait, have everything perfect, working, beautiful, wrapped up with the bow on top and everything. And at this point in my life, I'm like, you know what? No, I'm tired of that. I'm gonna be the opposite of perfectionist. I'm just gonna allow myself to look crazy, to fail, to flop, be rusty, and even dusty at times, if that means making progress. So this is like the little piece that I have worked on a little bit, and I still got some stuff to do with all of this over here. But go check out this because if you go here, you'll be able to see this survey. And this survey is a really important thing that I want to uh, invite you to be a part of. This survey is going to help me understand what is one motivating you to, tap into the world of software engineering, development, coding, programming, technology. It's just going to give me a little bit of an idea of like where your interests might lie. Now I know I can get this kind of stuff from like the YouTubes and the analytics and the dashboards and this, that, and third. But I don't want that. I want to hear from you. I want to hear from people who are really, really interested, who are willing to speak up. I don't want to just use extracted and scraped data. I feel like it doesn't really help that much. Okay, so if you could just go ahead and fill out the survey, this really helped me a lot. And I feel like my purpose in making this YouTube channel in general, the stream, all of this is really two things. It's twice-fold. Let's just go ahead and say it's twice-fold. It's three things. The first one is I want to make the best content possible that will actually be helpful. That's the purpose. That is the number one mission of this channel, is to make the best content that I can make to be helpful for whoever should come by this channel for whatever reason and for however long. I want you to be able to come here and find a little something that will help you on your way, on your journey, okay? Do not leave here without a little something. Little something, okay? In the words of the elder Denzel Washington, okay? So that's the first thing. The second thing is I'm trying to, and I hope I'm doing it in a way that doesn't feel cheesy, is I'm trying to show you that being a developer, being a coder, being a nerd, being a techie, it's some cool stuff. It's fun. We have fun. This does not have to be a boring thing. You do not need shoulder pads and a tie. Like, this is for us. This is for people like us. You know who we are. This is for us. That's the second thing. Okay. And the third thing is like, I know we live in a world right now where everything has to be about like money and business, all this other stuff. I'm trying to just show you here that what's going to get you as far as you want to go as an engineer, a techie, probably just in life in general, is to develop a real passion and a love for what you do. Anything that comes from love will prosper. And that includes this stuff as well. Okay. So the energy that you bring to what you do is going to translate. It'll have an impact, a consequence, an influence, a ripple effect, and all of that. So those are my three things. And maybe we'll come back and talk about that later. But for now, I got to stop talking and get into some coding. That's what we're here for. Okay. So let's go ahead and get back over to Boot.Dev. Bring the energy down. Still be a little spooky because we got the music going. But let's get into this. And my brain is probably a little rusty. Okay, so, ooh, I said a whole mouthful. Loud Jesus fire. Okay, so it says we're working on maps here, and this is a brand new problem. I still have 19 of these gems, and I know I'm going to buy a potion. My goal is to just get to level 33. And one of the things that I did not do well is I was too aggressive on the quest that I did, and I didn't really think through how much XP I was going to get within the 24 hours. So basically, I didn't get that chest. So I think what I need to do tonight, I need to like look ahead a little bit. So I know this one right here is going to give me about 500 XP or so, the one that we're on. And then we're going to go to chapter 10, and let's just look ahead and see what's all up in there. So these look like I can't remember exactly how much this is, but I know the ones where you code are worth more, and then the ones that are like the challenges at the end, they're worth the most. I like C1. So I feel like I'm probably gonna get, well, it's almost 9 o'clock. I probably got 2 hours of coding, which really means three, because I just be on here. I get lost in the sauce. I probably got 2 hours of coding in me. And I also happen to be really excited about pointers. I don't want to overestimate how much I can get done. I feel like I'm gonna at least get to the second quiz on pointers. Yeah, because I already know a little bit about pointers because the projects that I've been working on in the boring stream, that's a lot of pointer stuff. There's a lot of pointers and const and structs and interfaces. So I'm not an expert, but I feel like I'm not going to be as lost as I might be if I, haven't been doing that stuff. So that's I'm just going to take a guess here. This is might be like 150 XP. That might be 300, so 300 total. That might be another 150, so 450. I think these quizzes are like 75 or something like that. So I'm just going to go ahead and guess like 600 XP, and then I might get like 500 from this last map one. I think this one ends up being like 500 like base XP. Now, don't quote me on any of this because my memory is terrible. My brain is made for processing, not for memorizing numbers and things. But I think I might end up getting maybe like 1,000 XP in total if I get up to the point where I thought I was going to get up to. So if I take the XP potion, uh, ooh, okay, I made the mistake last time of thinking if I clicked it, I would get more information and wasted one. So I'm gonna Google it on my other screen here. Boot.Dev XP potion stream. I don't even know if this is gonna be on Google. Um, oh, maybe it was just XP potion. Okay, there's a blog post about how the game works. I'm gonna pull this up on my browser. Let's just go here. Boom, bap, shabbat. Okay. Go away, Speechify, hi player. So many pop-ups. Okay, so maybe we can look up here, XP potion? XP potion? Okay, temporary multiplier that you earn from completing a new assignment. You can buy XP potions by clicking the gem icon in the sidebar. As long as you have enough gems to activate it. After a potion gets activated, you receive 50% for all the assignments you complete within the next 30 minutes. So here's the thing. I cannot. I will not be able to get all the things done within 30 minutes. So what I'm gonna have to do, which I learned last time in this game, is be strategic about when I pop the potion. And the best time to pop a potion is going to be after one of these challenges, like C1, for example. Because when you turn in it, if you pop the potion, you turn in the challenge, you end up getting like a bunch of XP. Um, and then a challenge might take you like 30 minutes to do. So if you try to pop the thing at the beginning, you might not even be able to finish it. You're gonna be rushing, and rushing ain't bussing. So don't even do yourself like that. So okay, we're gonna save it for when we get to the end of this, when our run passes before we submit. And then hopefully that will get us through maybe like a couple of these pointer ones. We'll see. I'm not gonna be too pressed about it, to be honest. Like um I don't want to base my day of the game off of the XP potions because that's how they get you. It be them XP potions and magical crystals and golden gems. You chase that stuff and the game's no longer fun. Okay, so that's what we're gonna do. Okay, so I'm gonna be very modest. I'm gonna do the smallest chest today, and then if this is like just too easy, I'm gonna do the bigger one tomorrow. But I'm not even gonna. I want to get a chest. I want to get a chest that opened the fifth for me. I don't want to just have one and lose it. That's gonna be very, very disheartening. Okay, so maps are similar. Oh wait, we already did this. Oop. Okay, so here we are. There is a bug in the log and delete function. Fix it. Okay. Damn. Sure. I guess. No, I don't want to. Like, what do you want me to say? Uh, okay. I'm being very dramatic right now. Um, okay, so this function should always delete the user from the user's map, which is this here. And it is a map. It is basically a map of strings for the names of the properties that have users as their value. Destructive users, which is basically their object. I wonder why nobody at Go was just like, call it an object. Why you gotta call it a struct? I know it's probably different under the hood and everything, but why it gotta be so different? It's basically object, as far as I can see. Um, so yeah, the function should always delete the user from the user's map, and which is a map that stores the user's name as keys. It also returns a log string that indicates to the caller some information about the user's deletion. Ooh, got a little messaging here. Um, to avoid bugs like this in the future, instead of calling it delete before each return, just okay. So you can use defer. So what defer does is if you put defer in front of a method or a line of code or whatever, it is going to wait until the end of the scope in order for that code to run. So it's great for closing out things. It's great for doing final behaviors. Now here's one thing. I think it comes before the return still. It has to, right? I just want to make sure. And even if okay, I'm just gonna ask. Just gonna ask. Okay, so in GoLang, will a defer always run just before the return is executed? I'm assuming it does. It would be really strange if it didn't. I'd be very concerned and I would begin to question the entirety of my existence from my birth until this exact moment. Okay, I'm being very dramatic, but I'm waiting for the text to render. The thing about streaming. Okay, so yes, defers in Go will always run after the function's logic is complete, just before the function returns. They return in LIFO. So last in, first out. So last in, first out. Okay, so if you put a defer at the top, it'll run after whatever defers beneath it. So it's like a inverse direction, basically. So it all ends up at the bottom in some I'm wondering how this is working out in like memory. Ooh, my ears are like perking up like a little puppy because I'm so curious how that works out in memory. Uh, I'm gonna probably do a C one of these series at some point, probably for the C course they have. Okay, so defer. Okay, so then this defer runs before the return, and then the yep. So this will run first, and then this will run second, and then this will run third. Yep. Okay. Cool. Love it. Arguments to defer functions are evaluated immediately. Okay. We'll print. Oh, okay. So it'll still run last, but it'll only take into consideration um, things that it's dependent on as they were defined before that line in your code. So it's almost like, okay, I know a little bit about okay, apparently I don't know enough about it to remember what it's called, so let me shut up. Um, what's it called? I was reading that book. Ooh, the structure of it's called SICP. What's it called? I did a thing about it. I was reading it like last year. This book, Structure and Interpretation of Computer Programs, it's about interpreters. So when I am reading this here, this is making me think about something to do with how the interpreter, well, it's not an interpreter, it's not an interpret language, but something how the compiler is like, I don't know, there's just something that reminds me of what I read in that book. And maybe I should go back and read it because my brain is just like, firing off right now in all sorts of directions with this. This is very fascinating. GoLang is just such a fascinating language. I would say that. Or maybe I'm just at the point where I can appreciate it. Okay, so this will print. Obviously, it'll do this one last, this one second to last, and this one uh, first. The for even runs in when a panic occurs. So a panic is like an exception, from my understanding. Um, it's like a way to throw, basically, an exception. I think. Let me. Okay, let's look. There's a panic and except like an exception in JavaScript. I spelled that wrong, but we're gonna send it. I ain't even going front. I leave my typos. At this point in life, in this year of 2024, I'm not erasing no typos. I'm not retyping it. Is that terrible? That sounds so entitled. Okay, it's done. Is it pending? Yes, the pending is like an exception in JavaScript. That's all I need. Thank you. That's all I need. That's all I had to say. Uh, you gave me a whole bookshelf. I don't need all that. Okay, so common use cases for file. So this is the part I already knew this. This is like what you learn when you read like one of those like learn Go in 5 minutes. They love to tell you this part because it's just so different from like what you might, see in like some other languages and stuff. You can defer Go. So it's good. Like if you open a file, you have to close it because you're responsible for it while it's open. So you can have defer close it at the end of whatever scope that file is being used inside of. And then that way, because the file, when it's open, it's allocating probably some buffered amount of memory, or maybe, I don't know if it's buffered, but it's gonna be allocated to some memory somewhere. And you have to like, if this was like a lower language, you would be like responsible maybe for taking the memory that was reserved, emptying it, and then reallocating it. Or there's a word for it. Um, it's not it's like the opposite of fragmentation. It's you have to deallocate it for whatever it's been allocated for, and then you have to coalesce it back into whatever the adjacent blocks of memory are. So I imagine that this is probably why you have to close the file out, because under the hood there's some other sub process that this is somehow hooking into in the operating system that was probably written in a lower level language like C or something. Where let me I'm getting way too deep into this. I'm speculating, but it sounds convincing. So anyways, that's all cool and dandy. I'm glad I read that, but now we can go on. So what I'm taking from this is like we need to be able to send some um, message that is going to return a log string that indicates to the caller some information about the user's deletion. So to avoid bugs like this in the future, instead of calling delete before each return, just defer delete once at the beginning of the function. And so avoid bugs like this in the future. Okay. So let me just make sure I also returns a log string and indicates the caller. So let's run it. I want to see the bug in action. Can't solve it if you don't see the bug. We might even need to throw some consoles in here too. Um, but I mean, I'm not going to get too lost into that, but I love bug hunting. Love it, love it, love it. Okay, so these tests pass, and then you have one that fails. The one that fails here is that we never made the log for Bob. And then I want to understand maybe why. So let's just read this literally. So we have a function called log and delete that takes in a map where the keys are strings and the values are user structs, which have these properties. There's another argument called name that is of the type string. And then at the end of this function, we're going to return a log, and that is going to be the name of the thing that we return. And then we are going to make sure that that is always a string. And that's going to be type checking within the function. So first, we're going to go look at the user's object or the user's map. And we're going to check to see if the name that we have coming in is inside of this user's map. And if it is, then this is going to be true, this okay. And then if it is not, it's going to be false. And then if it is not in there, then users will be, I believe, null. And then, well, no, it won't be null. It'll be whatever the zero type is. So for a struct, the zero type is null. So it'll be a null struct. But if it does exist, then we'll get back the struct, and it'll be stored in this user's variable. So here we're saying if it is not there, then we are going to delete the user. We're going to delete the name from the user's. Wait, if it's not okay. So there's something here I'm not understanding, I'm supposing. So maybe this is what it's saying here. That we let's just continue reading. So if not okay, then we want to delete from the users the name of the person and say log not found. Okay. So if the name is not found in the user's map, then we want to remove the user. That doesn't really make sense to me. But anyways, if the user is an admin, then we want to return log admin. And then at the end, we want to delete the user from the name from the user's table and return. I don't know why this is here, to be honest with you, because we don't need to delete anything if it's not found. Maybe that's the problem. So it didn't break anything new for me to get rid of it. But I think what they're saying is that this delete here can go up top here like this, and then we could just do defer. So I'm going to try it this way. And in the words of the French people, voila. No, that wasn't that hard. But yeah, we did it. And you helped. Your energy was coming through the screen. And I needed it. And it got me where it needs to be. Bars. Okay, let's go ahead and move on. Let's admit that before we move on. Get our XP. Okay, we got 324 XP. That was quite a bit, to be honest. I wasn't expecting to get that much. So that probably would have been like 500. I think I overestimated when I was thinking about the numbers and the math and strategy and everything. I overestimated, I think. I think it's more like 500 with the XP potion, and then I was like saying like 600 or something. But anyways, that's fine. Okay, so that was it. Now we're on to pointers. We finished that, and now we're into the next thing. Introduction to pointers. As we have learned, a variable is a named location in memory. Yes. Like a namespace, perhaps. That stores a value. we can manipulate the value. By the way, let me just pause here and say you might be hearing some barking or whining in the background. I have a dog, and he's a puppy, and he's like 4 months old. He's he's 4 months and 3 weeks old. Yeah, so he's very young. And I just got him. Well, he already had this other crate, but I realized that the crate I was using was too big. Anyways, long story short, he's in a new crate that he's not used to. And I'm a little unsure if I should like take him out for relief or just let him acclimate. So I'm trying the acclimation strategy like I kind of had to do when I first got him. But it's been a little rough for him. So please forgive any like whining. He's not really a barker. Like he kind of deals with it, but he might be whining in the background. So I feel very bad for him, and it's very hard to focus. But I'm going to try to just power through it because you know what I'm saying. I'm a wolf daddy. I gotta be like you know what I'm saying. I gotta let him figure out his thing, and I'm here if he needs me. I'm gonna take him out here during my break anyways. So I just feel like I had to say that. So cool. Let's continue. Let's keep doing it. Okay, so um, when we assign a value to a variable, we are storing that value at a specific location in memory. Okay, so I'm just gonna say what I think or what I know because there's a video here, and I'm not gonna watch it because I don't know like what the policies are about watching other people's videos when you're in a video. I don't know if, like how that works. I'll look into that later. But the thing about pointers is that there's two signals, there's two symbols, there's two operators basically, um, and they both kind of work together and they do different things. So the first one you have here is the pointer, and then you also have this thing here, this operator, the and symbol. Okay. So this star here, this represents like the thing. Okay. And then if you're going to initialize a variable and you want to be able to have the address for that variable, I believe you need to do, and I'm going to confirm this here in a second, but I believe you need to initialize it with the star in front of it because that makes it a pointer as opposed to like a variable. And then if you ever want to retrieve the address of whatever that thing is that you've created, then you use the and symbol, and it'll give you like was it a hex code of whatever location it is in memory. Okay, so hopefully that helps because I'm not going to watch this video. Um, and I'll just go ahead and look it up here too. I'm just going to type in what I think the explanation is, and then I'll let this thing correct me because I want to activate my own thought process in this. I don't want to just ask it to tell me everything. So, and I do trust it that far, at least with coding things. So we'll say, please check my understanding of pointers and GoLang. And then I'll just write, my thoughts down here. So I think, let's see, there are two parts to the syntax. The first part is and the second is the star indicates that a variable or argument is a pointer, which is a way of referencing something such that it can be accessed directly in memory as opposed to a variable which is assigned which I'm assuming I'm just going to assume I'm assuming here I'm assuming cannot pass or cannot be cannot reveal its memory address. So let's see what it tells me, I guess. I don't know. I'm open-minded. I don't know everything. It's like some people are like, don't use AI to tell you things. I'm like, AI is just the internet. If you think about it, AI is just internet. It's just internet in a box and like kind of congealed into a certain, slice of bias. But it's just internet. That's all it is. It's internet. And internet is just people. If you really think about it. But That's neither here nor there. Um, okay, so it's gonna help me clarify. It says my understanding is partially correct. Okay, I had a little some. I got a little credit. Let me break it down for y'all. Okay, it's saying here, these are the operators. The star is used in two ways to declare the pointer type. That's what I had said. So this is the pointer to an integer. Okay. The deference pointer, let me make this a little wider. The deference pointer to get the value it points to. That's what I had mixed it. I didn't really say it so gracefully though. So this will get the integer value that is okay, value that P points to. Yes. Yeah, so P is pointing to something, and this is how we get the value. Okay. And the and symbol, the ampersand, I feel like people, when they say ampersand, it makes you feel like I know a little something about something. I saw an episode of Tiny Toons where they may have used the word in a comical way, one time in the 90s. It makes you feel like, you really, you're worldly, you've been places, you've done things. Ampersand. Just say it. Say it to yourself. It feels really good. So the ampersand is used to get the memory address of a variable. So if x is assigned, or if there's a variable called x that is assigned to the value of 5, okay, what is that there? Okay, I see. Um, and then p is the address of x. Okay. P now points to the memory. Oh, so you don't have to initialize something as a pointer. Okay. So okay, so maybe mm, so if wait, where's my GoLang playground? Let's just use this. This is gonna help me. Help me help you. Help me. But we're gonna adapt this. Let's just go ahead and here say my thing. My thing. I don't know what I'm putting here, but I'm just gonna keep reusing this for different things. I just want to test out something real quick. So it was saying that if we have, I'm gonna take this example actually. I'm just gonna toss you in here because I don't trust you. I don't trust AI that much. I'm not about to get bizarre myself. Okay. So we're gonna put that in there and then we're gonna put this in here. I'm just trying to see if you're lying. I'm not saying I don't trust you. I'm just saying I'm gonna check. Them's two different things. Don't be mad. Okay. So let's run this. Uh am I forgetting something? Oh, I'm sorry. These are actually two different type of things. Let me do one at a time. So we're gonna do I can't do it doesn't have a shortcut for comments in there. Undefined P line 12. Um what was I supposed to have done? Okay, I forgot this part up here. I don't know why. I feel like I'm just a way goofier when I'm streaming. Maybe I'm like just allowing myself to have fun. Maybe that could be it. Perhaps. Maybe. Okay. See, coding is cool. Coding is fun. I'm a cool mom. Not like the other moms. Okay, so let's try to run this. Ooh. Let me add some spacing here because I'm going to get confused. And we don't need all these comments either. I need to make this as easy for me to actually read as possible. Why don't they have syntax highlighting on the Go Playground website? I thought you people were at Google or something. That sure would help make the language more attractive. Just saying. Jeez. Make it easy on people. For Pete's sake. Okay. Um, and then what is it saying here? Line number 11. I'm having a decode an example from AI. That's the problem. Declare but not use the value. Oh, so this right here. So I think I can just delete this. And what I'm really trying to do is just make it where my console log is, we need a variable here. So let's put P in here. And I want to see the difference between me putting the pointer for this X versus the ampersand versus just the X itself. I know, I think I know what differences there would be, but I just need to see. Let's get rid of this here too. One thing at a time. This is why I don't get as much done as possible because I feel like I gotta go back and be like real detailed in all of this. I need to understand. I need to know. I need to know. Okay, so as I suspected, this is just the address. I knew that. I knew that. So let's make a new one. Let's make Q, and this will just be a star X. And let's take this and just put it in there next to it. Okay, so I don't like the word. I don't like the fact that I chose the word thing because I don't know. It's just a weird word. It's like moist or something to me in my mind. Uh, sorry. Let me just say my var. Let's just make this neutral, okay? We don't even need to go there. We do not need to go there tonight. Not on this Wednesday. Okay, so um Q. Let's do Q now and see what that does. Yeah, I'm gonna need to email somebody about this whole situation setup thing. This is not cool. I don't use this a lot, but I'm trying to use it for the stream. This is not friendly for people who don't know about this language, um, who don't know a lot about this language. Oh, you know what? I'm gonna do star P here in a second, but for now, I'm gonna change this to a star here and put it down here because I do want to see what happens if I um have okay wait, not use P. Oh, you were giving me such a hard time here. Okay, P. Indirect X cannot indirect X. What does that mean? So I can't make a pointer to a thing that already exists? Okay, that's an interesting nuance. Let's just double check that. So um let's say this appears to create an error. Maybe you can tell me why. Since you know all the things, since you know so much. Okay. Uh you have the operators reversed. No. I want to understand why. I know that it's reversed. I want to understand why this doesn't work. I know that it's wrong, buddy. How? Bucko. Someone told me recently, by the way, that I have a tendency to be polite when I when I use AI, or someone just pointed out to me, like one of my students, and I was like, "Really? It's because I'm Southern or something." But then I'm like, "Is there like a subconscious reason why I'm being nice to AI? Or maybe I just like feel like there's no need to be mean. I don't know. I don't want to get hunted when the robots start to do more than walk. Maybe I don't. Maybe they might see this video." Okay, so let me explain why P equals star X doesn't work. It's just a regular integer, not a pointer. Okay, so you can't do deference, or you can't so this is to dereference. I see. I don't know if I'm dyslexic, because I definitely was not reading that word correctly, and I know my dad is. Ooh, that would be terrible. I need to get tested. I don't think I am. Ooh, dereference. Why am I seeing deference? Is it because it's late at night and I'm a mid-30s person and stressed out? Oh gosh, so much going on. Okay, so you cannot dereference a non-pointer value because dereferencing means follow this memory address to get the value stored there. Okay, well, I was gonna ask a stupid question, but I'm not gonna do that. Uh, okay, so what if I made X this number? Would that work? Okay, so it doesn't work. 'Cause- can you do this? I'm just gonna try this. What happens if you do that? Put the ampersand in front of the memory address. Okay, so you cannot use the ampersand in front of an address? That seems like it should work because what if you have another process that stores something in memory and you need to use this code to go to that memory location and pick it up and then do whatever you're trying to do with it. Like let's say you have a server and you have two different compiled languages and or not even compiled but just two late languages that have access to lower level memory, and you want to be able to pass information to both between them indirectly by storing something directly in memory with one and picking it up with another. This is something I kind of thought about like when it was coming when I was like learning about no, what was I doing? Oh, I know what it was. I was working on a project where it was like a JavaScript server. But there was like, oh, I remember now. Sorry, my eyes just got really bulgy. I remember now. Okay, so I was working on using Python to do some natural language processing stuff. And I was like thinking about how I could build a server with the natural language processing. And the stuff I was doing was like using Hugging Face. And anyways, it was like going externally to, to do some of these algorithms or whatever. It was like an external resource that it was using. And what I was thinking is maybe I need to have some locally hosted solution for something that's like generative or AI or even just like a machine learning. And if I had a Python server, I would have so many limitations on the memory. So maybe I can use GoLang, or maybe I can use another language like C in order to be like a to run a task for me, and then I can have like some type of worker, so to speak, that runs that task but in another language, executes it, and then stores whatever the result of that task is, which for example could be the result of from like a natural language thing or maybe some data processing, and just store it directly in memory so that it can be scooped up and then continue to be used, and then maybe be behind some type of like asynchronous handler or something like that so that you know when that process is done. So I was thinking about something like that. So I know that being able to pass like two things for in memory does work, and it also is extremely efficient in terms of performance because having to like read from a file is way slower than reading directly from memory, which is why this stuff even exists in the first place. So I would be very surprised. I'm doing all of this, yapping. Let's just ask Claude, and then maybe I'll just see how my confidence in the answer feels. Let's just do that. So, ignoring everything that it says here, I'm just gonna ask my question because my ADHD is getting ahead of me. So I know that it's possible to store something in memory. But if something was already in memory, let's say from another process, this dang taskbar at the bottom is just killing me. Okay, there you go. Okay, so another process. So memory is, let's say, but if something is already in memory, let's say from another process, couldn't or isn't there a way in GoLang to use a memory address to access that information? Also, if I were working on a data structure like a linked list, I got too many commas in it. I go comma crazy. I feel like a sentence should just have maybe two commas at the most, but uh, like a linked list. Okay, if I was working on like a linked list, couldn't I have another process that is technically working on the same linked list by having access to the head in both processes, or by some method having access to the head and by let's just say some function functionality in both processes having access to the head. Let's just get our language right. Can we just do that? Okay, if it doesn't make sense, I'm sure it'll make an inference. Whew. I've been streaming for almost an hour, so I think it's almost time for a break, but we'll just we'll finish this. We'll finish what we started here, and then we'll take a break. Okay, so it's thinking. I must have asked it a heck of a question. It's struggling. Maybe we need to start a new chat. I think that might be what it is. Something that I theorized in my head is that I don't know I know that chats get really slow the longer you have them. I don't know the exact reason, but I do know that these chats are being streamed, and streaming is a different usage of memory than sending like a complete thing all at once. And so when you stream, you have to hold a lot more in memory, or you hold a lot more in memory, which is why you stream because it's more efficient to do it in the stream because you don't have to have as much memory allocated in order for that to happen. You can empty memory as soon as you send it. Okay, so there just might be a lot going on. So starting to chat. Oh, I need to be very clear about memory access between processes as this touches on some important system programming. Okay, so while we can work with memory addresses and Go using pointers, processes typically cannot directly access each other's memory space. Okay, so that I did not know that. I know that it's possible to kind of go around that, and like maybe like C or something. I know that that exists because I've looked into it. Um, but this is actually kind of cool. Like I like this idea. This makes a lot of sense. So when a program runs, it has a type of ownership. Maybe I don't know if that's the word, but it must have some type of ownership or some type of ability to keep track of what it has um, requisitioned from an otherwise shared pool of physical memory. Okay, don't get too greedy. This is a fundamental security feature of modern operating systems that prevents one process from reading and corrupting another process. Remember, what if you want to do it? What if you want to do it to make your code run faster or to make use of multiple languages with fewer barriers? Yeah, but that is risky. I can understand that. Probably possible on Linux. Everything's possible on Linux. Here's what's possible and what isn't. Within a single process, so this line working with pointers in the same process. Okay, so this is the address, this is the dereference. Yes. Okay, so within a single process, you could do all of this. You could do all of this, but they didn't tell us anything about this part right here. But it's okay. I mean, they're avoiding the question. Okay, so between processes, by default, processes cannot access each other's memory space. To share memory between processes, you need a specific mechanism. Oh, I think yeah. I think when I was looking into this, it was this thing right here, an IPC mechanism, inter-process communication. That's what we was looking for. Okay, that's cool. I'm glad I remember that. I don't think I'm going to do that project anymore, but I do like the idea of inter-process communication. I am an air sign, you know. We love communicating. Okay, so shared memory segments. Oh gosh, I want to go on the rabbit hole with this so bad. Memory. I'm gonna take that C course that they just added here on Boot.Dev. To be completely honest with you, I part of me wants to just be like, this Go stuff. Let's go do C, but I ain't gonna do that. I really do like Go, but that C, that lower level language, something about that just make you feel proud of yourself when you start understanding it. It feels very good. It's very validating. So these are the three ways we could share memory between processes. I'm sure that this is probably all way more complicated than I think it should be, just because of the security stuff. But it makes sense because you don't want to actually access memory like actually directly because you have other stuff in there that you do not want to be playing around with, even on accident. Could you imagine accidentally overriding something essential for your computer to even turn on? Like you just messing around, writing a program, and you have a typo, and now your computer won't turn on, or your browser doesn't open up, or your password no longer works. That'd be crazy. Okay, so for your linked list example, if you want multiple processes to work on the same data structure, you would need to use proper IPC mechanisms like shared memory segments, message passing, mapped files, implement proper synchronization to prevent data races. Oh, there's a data race. That's like a race condition, I guess is what it's saying. Or unless that's something different in this context. I'm assuming it's the same thing as a race condition, or the same idea of a race condition that you might have to treat with two different pieces of infrastructure. Um, race like async, basically. Is that what it's trying to say? Here's a safer approach to using shared memory and Go. Okay, so there is something built in. I'm assuming. Yes, syscall. I don't know if this is built in. I'm assuming this is built in because it doesn't have like the GitHub whatever in front of it. This comes with the language. So okay, this is opening a file. This right here, these are permissions. When I first saw this, I think my eyes bulged almost in the shape of these O's. I was very wide-eyed and confused. But these are just permissions. Wait. Yeah, these are permissions here. Um, let me be more specific. These are permissions for what can be done when the file is opened, I believe, and I think these are permissions for what the file. These are permissions for the file. I think in general. Uh, I need to confirm that. I do know that these are methods, so these are modifying this OS thing. I don't know. I need to look into that. I don't like not knowing, but this is going to cause me to go down another rabbit hole. So, I'll just defer that. Okay, so. If error is not nil, panic sure. So this is mapping file into memory. So syscall is the import that does that in mmap. And then what does this do? This takes in FD. What is that? Zero size. Okay. Why do I feel like there's some variables here that have not been defined anywhere? Okay, syscall. Where does size come from? Am I overlooking it? Does anyone see this? What is size? Okay, so anyways, let's just go ahead. If you're specifically interested in working with data structures across processes, you might want to consider using a database. Well, duh. Using message queues, implementing a client server. So a message queue would be like having a piece of software that is running, and its responsibility is to manage messaging, and then messaging queues is like one way of doing that. Implementing a client server architecture, sure. I'm kind of tired of making servers, to be honest. I feel like I want to make other things. Not everything needs to be a web app. Everything's a web app these days. Back in my day, there was no web app. Actually, there was, but you know what I'm saying? I want to code other things. So, okay, it really is interesting. I mean, that's one of the reasons why servers were created. For this issue of sharing things between processes, between infrastructure, hardware, whatever. Using distributed data structures specifically designed for this purpose. Yes, distributed data structures. Exactly. These processes are generally safer and more maintainable. So. Okay, cool. Okay, so I was just trying to see if I could do this. I think I have an idea about what all is happening now. So the key thing I walked away from all that tangent, is that the star is to dereference, and what that means is you're tracing down whatever the address of something is. And the star, when it's used in the creation of a variable, it makes it into a reference type. I think the one thing I didn't figure out here is if I made a variable called p that is an integer, can I still get the I can't get the address of it. Let me just make sure here, and then we'll move on. I can. So it doesn't matter if I make it into a um okay, okay. Let's we gotta ask another question. We do. I have to. This is the grind. that's going to make us really excellent programmers or whatever we do. You got to ask all these questions. And this is my time. I can do whatever I want to do. I'm grown. Shoot. Okay, so I'm going to say here that um, that as well as this, and I'm going to say down here below. I use the 3 lines here because in Markdown that separates things. In my mind, I feel like it helps AI know that this stuff up here is grouped together, and the stuff down below is what you need to read. So these examples appear to console log the same thing. So my assumption is that we do not need to initialize something as a pointer in order to get the address using the, I'm going to type the word ampersand. I don't even know if that's how you spell it, but typing it is almost as validating as knowing the word. You know what I'm saying? Do you feel what I'm feeling? We're part of like the small percentage of people who care. Care about something that is not even, you know, that valuable. But we do. Correct. So you can get the memory address from any variable using the AND operator, regardless of whether the variable is declared as a pointer or not. Let me explain the difference between your examples. So one is a pointer variable, one is an integer variable. The pointer points to the address, to the pointer address, pointer variable itself. Prints to the pointer variable itself. Okay, so the AND operator gets the memory address of any variable. A pointer variable is just a variable that stores a memory address. Oh, okay. So okay. So then my next question is, if I just put P in here, will that work? Okay, it doesn't. Okay, so when something is declared as a pointer, it is an address, and you can only use it if you use the ampersand, because the pointer is, this is the actual thing that points to the memory. This is just the way, and when we do this down here, it accesses the value, but this is the way you get that address. Otherwise, it's just a relationship. It's not a thing. This is still a little bit mind bendy. Okay, let's just continue. So this is the address of the integer variable, and this is the address of the pointer that points to the integer that's stored in a memory address. Let's type that out, but we'll wait to submit it till we finish reading this. I'll just copy this. So from this example, are you saying that the first one prints the address of the variable, the address of the, I'm sorry, not the variable, the address of the pointer, which is separate from which is its own type of data structure? Which has the job of maintaining a relationship, which has the job of the data structure, which has the job of containing the relationship, or not containing, what I'm trying to say, has a job of referencing something in memory. Which has the job of referencing something in memory. Whereas the second one is so the one prints the address of a pointer, which is its own type of data structure, which has the job of referencing something in memory. And the second one is the address of the actual thing in memory without a pointer associated with it. So with these two, the main thing is that a pointer, um, so the main thing is that a pointer is just a connection to something, whereas a variable, so, but isn't a variable pointing to something in memory? It's just a letter. Just a letter. Uh, okay, wait. So these two things, so with these two, the main thing is that a pointer is just a connection to something, which is an address, which we can identify as an address, which we can view as an address, which we can view as an address. If we use the pointer with the star, then we get the value of what the pointer is pointing to. And a pointer can be, I don't know if a pointer can be repointed, but a variable can be repointed as well, like a var can. Okay, so whereas the variable, or wait, so we can say the second one, the second one is the address. Okay, so if you use a pointer with a star, let's put the actual star here. So with these two, the main thing is that the pointer is just a connection to something which we can view as an address. Um, with If we use the pointer with the star, then we get the value of the thing it's pointing to. With a regular variable, wait, so a pointer, why does a pointer need to do anything? Why is it doing anything different than a regular variable? That's the part I think I'm having a hard time understanding. Maybe I'm just going to leave this part here and I'll just ask my question. Doesn't a variable just point to something in memory and store it in a namespace? I don't know. I'm probably getting way too deep into this. I'm going to wait to read that. I'm just going to finish this though. Okay, so the pointer variable, it's just a variable that stores a memory address. Okay, so maybe when it's a pointer, that's just a way of saying this is just an address. If anything encounters this, you need to know that this is just an address. This is not a string. This is not anything else. Do not treat it as anything else. This is just an address. Don't get confused. When you use the ampersand variable, you get the address of that pointer, not what it points to. I know that, okay. Regular integer variable pointer to variable storing address at X. So you can convert a regular variable into a pointer by passing the address into a new variable of a pointer. Wait, or so it's just making a new pointer for the variable X. Okay, so maybe why this matters is because typically you don't have two variables that hold the same exact thing. And maybe you want to have multiple variables, so to speak, that are able to point to the same thing, maybe within two different scopes, so that you don't have to pass something as an argument. Um, I'm just going to hold that thought there, but that's kind of what it seems. Address of X, same address of X. Yes. Different, different address, different address of pointer variable. Okay, so Okay, so yes, yes, yes. So the pointer and the thing that it points to are separate things, but you can have multiple pointers that point to the same thing. Each of those pointers have their own address, but the thing that they point to has that one address. Ooh, child. Lord have mercy. Oh, the way that that sounded coming out between my lips was wild. That was, I'm crying right now. Like the, oh my goodness. That was a wild, like, phrase of words, statement. Lord have mercy. Okay, so 42, dereferencing P to get X's value. Yeah, that makes sense. I think I kind of get it, but let's go ahead and read what it said for my other question. I'm gonna take a break after this because if I don't, I'm gonna be here and it's gonna be like 3 o'clock in the morning because I really be getting into this. So I gotta force myself to take a break. So let me break this down carefully. First, you're right that all variables in Go are essentially names that map to locations in memory. So in that sense, yes, every variable is like a pointer to some memory location. That's why I had said it. However, there's an important distinction with explicit pointer types. Let me visualize it. So scenario one, the regular variable. Variable x int is 42. Memory might look like, okay, X maps directly to this location. Yes. So scenario two is a pointer variable. Ooh, this is juicy. Why do I feel like this is tea that's being spilled? I mean, the nerdiest form, of course. Um, Nerds flavored tea sounds like a delicious treat. That's what this is. Pointer variable. Okay, so this is just a regular variable y. This is the pointer to the address of the variable y. This pointer has its own address, however. Memory might look like this is the address of 42, of the y. Y maps to this location. Okay. And p maps to this location, which contains the address. Ooh, okay. Yeah, 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 yeah. So I can have many, many pointers for the same content, for the same thingy, for the same thing. Basically. Okay, this makes a lot of sense. This makes a lot of sense because if you were to use like a regular equal sign, that would override, like if you did in some languages, if you did like A equals B and then you did C equals B, in some languages that would just make a new copy in memory of what was reassigned. Or I'll just type it out here. This is not, I don't think this is how GoLang works, but in some languages it's like if you do A equals B and then you do C equals B. In some languages, this is just how you copy whatever this data is that A is associated with, you make a copy and you add it to you assign it to C. But I think what they're saying here is that maybe let's just do a little test, I guess. So let's do A equals 1, B or C equals A, and then we'll now say A equals 2, C equals 1, or no, C equals A. No, no, no. C equals let's just say A equals, let's make B here. B equals A. And then now we'll say um so if both these are not pointers, but what I'm trying to see is if I were to change C um plus plus here, let's just do it like this. Then we can see what happens. A is not going to change, but we need to just prove that. Because I don't trust nothing in these streets. So let's just put C in here. Oh, sorry, my bad. My bad. Tried to use you, and I didn't even initialize you. I like initialization in GoLang, by the way. So if I were to put A in here, A is not going to change. A will always just be 1. Duh. Yeah. Okay. I mean, but I think the thing that they're trying to say is like, if this was a pointer, so let's say, and we're gonna just test this, I guess. Let's just say var a int or star int. This is how you really get into the juice of things, is by doing this, what we're doing right now. This is where the learning really happens, by getting lost and just going for it. Okay, so in order to, I don't need to make a pointer, but I do need to use the reference here, and then A should be 2. Oh, I didn't do this right. Oh, I got to use the ampersand. My bad. See, I don't do pointers a lot. I have to look for where the ampersand is on the keyboard. That's how you know I don't do a lot. I get it now. I totally get it. Oh, not completely, but I get it enough. I do get it now. Yeah, I see what I see what you got going on. So if I made a new variable here and I said var abcd star int equals ampersand ampersand a, and then I did c or star c plus plus, then a should end up being 3. Oh, wait. Let's do D plus plus. It doesn't really matter. If I do D plus plus, then I can put D in here. We need the star. Uh uh Star. Okay, yeah. That's what I was expecting. Okay, so cool. So you can have multiple pointers that can share a same value. That is where the meat, the juice, the good stuff therein lies. Okay, I feel like that is more simple than it appeared to be up until this point in my life. I'm going to be completely honest with you. I've been programming since professionally since 2018. I've never had to deal with pointers in a job, at least. And this moment of me going on this big tangent is like, wow, they could have just said it that simply. Okay, let me just say what I think in my head, and hopefully this is as helpful for you as it was for me. So this example right here, what this is basically showing us here is that you can have one variable that is assigned to a value, and if you change that variable, then that value no longer exists, right? Um, if you have a reassignment where you try to move that value to another variable, it is going to make a copy of that, of whatever that value is, and put it in the new variable. It is not going to be referencing the same data. Now, this is not true for every language, but certainly for GoLang it is. It's not, doesn't work like that in JavaScript, as far as my knowledge goes, because objects in JavaScript, they, they don't make copies when you do reassignment. Um, it's the same object, and that's being used in both instances, or both variables. So here, I think what this is saying is that you could have many pointers that point to the same thing, and they can even point to something that a variable holds. But if you don't have if you don't have the a variable initialized as a pointer, and then you go do like this reassignment stuff here, then it's just going to do a bunch of copying and like overwriting. But if you have the pointer here, then the pointer is just a reference. And if this pointer refers to something in memory here, this pointer can also point to the same thing. So that if I change this pointer's value, it will also change this pointer's value. In fact, I think we should prove that here. And we'll just put, let's just make this a little bit easier. So we'll put D hyphen that value, and then we'll put C hyphen another value. So these two numbers should be the same. If it's not, my world and my ego are both destroyed because I went through that explanation. But they are the same. Sorry, I said that very loud. My neighbor is probably very upset at this moment. Uh, my bad. Sorry. But yeah. Okay, so I feel like this is like diagram worthy. But okay, so I'm gonna let that sit. I'm gonna let that marinate, let that bake, throw a little salt on it. I'm gonna take a break. And then when we come back, we're gonna go ahead and pop back into this. And I feel like because we took the time to really dig into that, also we didn't waste our XP potion. We still got that. Good thing we didn't use it at the beginning. Talk about min-maxing and metagame. But now that I took the time to understand all of that, I feel like this is gonna be a lot easier. So let me give you this one piece of advice that I would give any student of mine who's learning anything in tech. When you're kind of like learning something new, take the time to investigate the topic, not like to the ends of the world, but just so that you know how to use it functionally. And this is how you do that. I mean, reading the documentation is great in and of itself, but this is the part that actually matters for what you're trying to accomplish. And if you understand it through working with it, it's going to stick much further. And then by the time you get to algorithms and stuff, you don't have to worry about the basic concept. You're thinking about how to string that together with other pieces of logic that you already know how to do. I think that's a good philosophy. It's a good perspective. So I know I'm going to go think about that a lot more because this and other things that we do here often remind me and reify that point for me every single day of my life. And I hope that sticks with someone out there who's watching this video now. Okay, so I'm gonna stop yammering. I'm gonna take a break and enjoy this brand new illustration that I got from Midjourney. That is our new break image. It's a little bit of a snooze fest because I may or may not go lay down, but I won't tell you. Okay, I'll be back. Give me 15 minutes. I'll be back here at 10:15 Central Standard Time. If you go far, don't go too far. Come on back, Wolfpack. Ooh, I hope you like this spooky music because this is going to be a very spooky week. And in general, I'm here for it. Um, I like that the music kind of fits the vibe I got going on here. Yeah, happy early Halloween, which is like one of the best holidays, low key. Okay, so we're back at this, and I'm just going to go ahead and jump into this problem. We've done a lot of reading, researching, digging, diving, exploring. The iceberg is very, very bigly under the surface. And by under the surface, what I mean is like in the lower levels of the computer stuff. But it was worth taking a little bit of a dive into that because we need to know some things about this in order to solve these bugs. So what this down here basically says that there's a bug here. It didn't tell me what it was, but if we run this, we will see the bug, and we just gotta fix it. So it's saying here that it's wanting this, but it's getting this. So it's getting the wrong wait. Oh, so it's saying we're getting like these addresses instead of getting the string. So I think what we need to do here is we need to just get the use the pointer instead of the we need to use a dereference instead of the ampersand. Oh wait, never mind. To precocious. Um. Okay, so I think what we need to do is make a pointer for each of these, and then wait. Let me not be too. Wait, so we don't need the ampersand? This can't be that simple. Dude, that's the thing about it. Sometimes we psych ourselves out. I was actually um I was actually kind of like talking to someone about this recently. Like sometimes the questions aren't really as complicated as you think, but you can trick yourself. Like sometimes knowing too much makes you like think everything's complicated. That's the point. Okay, so let's go ahead. My dog is really like upset right now. I took him out to go potty, and then I was like feeling a little bad because he doesn't like the new crate, even though it's like the appropriate size for him. And when he like whines, it sounds like it sounds like a skid, like a shoe skidding against linoleum. Uh, he used to sound like a little tiny chicken, so I used to call him that. That was his old nickname. But now he's advanced from a chicken to a tire to rubber against linoleum. So yeah, but all of his needs are met. So I'm just gonna go ahead and let the process unfold as they told me in the training class. The guilt of being a parent. Okay, so let's just try to focus on this, and then I'll be on here for like until let's do another 45 minutes. So it's possible to define an empty pointer, for example, an empty pointer to an integer. Cool. Yeah. So we're saying that we're gonna have a pointer that's going to store an address. Nothing lives at that address right now, but when something does, it will be an integer. So the only thing is, okay, so it's going to give us type nil because nothing exists in memory. Okay. If its zero value is nil, which means it doesn't point to memory address. So nil, okay, nil means it doesn't point to any memory address. This is one thing I need to figure out. What's the difference between nil and null? I've never even thought to ask that. I just deal with it. Usually I just deal with it. Usually I'm not responsible for it in coding. In Go, specifically, nil is used. Well, so it's the same thing. Okay, so nil is they serve the same purpose, representing a zero value of some types. However, there are important distinctions. Okay. Oh, nils can't be assigned to a string. Okay, so it's just a zero. This is zero value of some types. Okay, yeah, I knew that. It's like a zero value of a struct. Oh no, it's a zero value of a map and a zero value of a slice. That's what I meant to say. Is no, 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 that's not right. Yeah. That's what's saying up here. Okay, cool. So I guess my next question is, what's the difference? I feel like I should know this, but difference between undefined and nil. I spelled nil wrong. It's only 3 letters. Okay. The data difference defines that nil undefined means it doesn't exist. It hasn't been defined yet. Nil means it exists but has no value. Okay. It varies by language. So this automatically initializes to 0. This automatically initializes to nil because it doesn't have a value, even though it exists. Sure. Why not? I mean, that makes sense everywhere else in nature, right? Absolutely. You know, it's the ghost. It's the ghost without the shell. Or is it the shell without the ghost? Who knows? Go doesn't have undefined. Everything is 0 value. I feel like I didn't know that, but now I do. Okay, you can't do this in Go. So Go doesn't have an undefined, but JavaScript does. But JavaScript has a null. So you can make a variable in JavaScript that has no value, and that's different from undefined. Oh, Lord. Jesus. So null is just an object because everything in JavaScript is an object? Okay. My brain. So null has methods? Null can have a if it's an object. Oh gosh, that's mind bendy. Okay, I'm not going to go into that. That's a whole nother language, but that's fascinating. I feel like I need to do at some point like the same project in both languages, or like multiple projects in both languages to compare the two. And that will teach me a lot about either. Okay, so it's possible to define an empty pointer, for example, when the integer is nil. Instead of, okay, so which means it doesn't point to anything in memory. Empty pointers are also called nil pointers. Instead of starting with a nil pointer, it's common to use the and operator to get the pointer of its operand. Yeah, that makes sense. Okay, yeah. The ref operator up to the pointer to get the original value. Okay, I wonder if there's some process or something that occurs that facilitates it. I just feel like there's something in between all of that, this dereferencing thing, that I just wish I knew. Involve some, I think the word I might want to use is serializing process. Um, Hopefully that's the right question. No, dereferencing is not a serialization process. It's direct memory access operation. But does it use the same thing to get the value that a regular variable? Like that's what I want to know. Is there some like code that runs that says, "Hey, this is an address. We need to figure out where the memory is for this," or does the letter literally connect through the wires and fiber, the pixels? I have like the spidey sense that there's something in between all of that. Do you ever have that sense when you're coding, you're like, there's something that's happening here, and I feel it, but I don't know what the word is for it, and I don't know what it's called, but I feel like there's something there. I have a sixth sense. I see nil people. Do thing. So it means go to this paper addresser and read write the value. Okay. Directly reads the value. I guess whenever you're writing any code, this is technically just a way of running even lower level um, operations and whatnot. Okay. Directly reads the value. This bot's probably like, boy, just get going with what you're doing. This bot's probably annoyed at me. I feel like that's the one thing about AI is that it doesn't get annoyed. If there's any saving grace, like if everyone's like, I hate AI, I don't like it, I'll just be like, hey, you know what? AI will never get annoyed at you. Whatever questions you ask, however much sass you give it, is never going to be like, boy, please. And if it does, we're not going to take it serious. So that's one of the saving graces of it. I can just be as annoying as possible, annoying and ASCII as possible. Okay, so serialization on the hand involves converting data structure or object into a format that can be stored and transmitted. That's not the word I was looking for. Is there a process or something that is responsible for that chain, that that data, and actually doing the read or write operation? Like some deeper esoteric inner or lower operation of sorts. Talk about creative language. Yes, there's several lower level components involved when you dereference a pointer. Okay, that's what I'm trying to get to. And my next question is, are there memory implications that are significant between getting something with a pointer versus accessing it directly through a variable? That's what I really want to know. Maybe that's what all this has been bringing me to. Are there like a memory implication? Am I losing something and doing it either way? Other than the part where pointers can be shared between the same with the same value. The memory hierarchy: CPU registers, CPU cache, RAM, virtual memory, and on disk. Um, ooh, my dog is like, he hears me talking, so that probably makes him feel like he needs to bark. He might not even be barking out of upset. He might just be barking to like participate in the communication. He's more like doing like his little pup yell howls. They're not quite like, there's not yelps, but it's like a little howlish bark. I think he's like slowly evolving into a howler, which would fit into the Wolfpack theme, I guess. So, key components involved: memory management unit translates virtual addresses into a physical address. Okay. This might be getting too deep into the weeds. Virtual address, what your program sees. Okay, yes, yes, yes. This is the actual location of the hardware. So there's this thing. So when we get this number for the address, like this here, there's something that says, hey, this is a numerical representation of the actual physical location, and that's called the MMU, Memory Management Unit. Virtual memory pages, physical memory frames. So is this saying that this is actually a virtual address? Okay. Yeah, 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 yeah. Okay. 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 So what happens when you dereference? Program, oh, excuse me, central TPU sends virtual address to MMU. MMU checks the page tables. If the page is in memory, translates to physical address, checks permissions. CPU cache looks for the value. If not, the cache retrieves from RAM. So when we store a variable, variables are always stored in RAM, which is random access memory. And oh, well, it doesn't have to exist in RAM. It can exist in CPU cache. I don't know why it would exist in the CPU cache. Um, the cache is like a key value store. Okay. Value return to program. This right here is some nerds flavored tea. It's very sweet. This right here, this is like delicious. Love that. Common issues with this system handles. So, what would happen if you had something in memory that didn't exist in the page tables? That sounds like something that's like not good. Like if someone's like really bad or whatever, they'd probably do that. And then my other question is, what happens if something is in the page table but it's not in memory? What happens when it encounters that? There's probably the risk of like some critical failure with the system, especially if that's a thing that's needed or needs to be referenced for some like important process. Huh. Huh. I wonder what's responsible for keeping the page tables aligned with what's actually in memory. Like, is there something that, like a continuous process that checks out? Okay. Well, anyways, that's a great question. What I need to start doing in the future is like keeping a little notepad or something inside of here where we can like put our random questions because these are great questions, but I have to move on. So the star operator dereferences a pointer to get the original value, unlike C. Go has no pointer arithmetic. What is that? Oh, so we have to dereference in order to change. And oh, oh, that's weird. Oh, dude. What? Whoa. Hold on. Yo. Okay. Okay. Ooh. Okay. We can't go down that rabbit hole tonight. Ooh. Oh, I'm reminding myself of my little puppy. When I take my puppy to the park, if he sees a rabbit, he wants to chase it. He just has to. He sees my dog gets so excited when he sees a rabbit, a squirrel, another dog, or anything that just moves. That she starts shaking. And my dog is actually very, very socialized. I take him to pre-K and everything. We're in life skills 101 right now. But my dog, he everything's something to play with, and everything's a potential friend. He's just like this, like, oh my gosh, I need it. I need that rabbit to be my friend right now. And I don't know what he would do if he got the rabbit. He might be scared because he's actually a little scaredy cat. But that's how I feel when I'm like reading this stuff. I'm like, oh man, look at this. That is cray cray. You can do that in C. For real? Okay. All right, well we gonna let it go. We gonna let we gonna let it be. We ain't gonna chase that too far. But I'm gonna keep this open so I can nerd out in the wee hours of the night when I'm supposed to be asleep because I got work in the morning. So complete the remove profanity function. Sh- No. What if I don't want to? I'm gonna do it. Okay. It should use the string dot replace all function to replace all instances of the following word in the input. Those aren't real cuss words. It sounds like lingo from when I was a teenager. Back in the 90s. Actually, it was actually the 2000s. I'm not that old. Come on. Okay, so word replacement. Okay. It should update the value in the pointer and return nothing. Nothing. We want to okay, so and return nothing. Okay, so we don't have to do anything. Oh yeah, yeah. That's the nice thing about a pointer is we can change something that doesn't exist in the scope. That's how we got it. Okay, so we're gonna go to the message string. We're gonna do string dot. We're gonna make a. We're gonna make a. We need to make a. Let's make a slice. No, we can just make an array. So we're making an array of. We'll just say words or profanities, and then we'll say the slice of string, and then we'll do fub is and which. I feel like I know what these words are supposed to be. You know, it's like it's like these kind of words are like Nickelodeon cuss words. Back in the '90s, at least, when I was a child, not a teenager. This is like the kind of words that they would say in like Ren and Stimpy. And you're watching as a kid, and you're like, "Oh, that's a cool word." And then your parents are like, "Yeah, this show has another context and meaning," and we get to laugh as well. Okay, so we don't need to have a data structure for the actual replacements because what we can do is we can do a switch. No, no, we don't need a switch. Yeah, we need a switch. No, no, we don't need a switch. We can just do replace all for each of these. Okay, is that all? I maybe we don't even need this. I should have just wrote my comments. That probably would have helped. So we can just do message. We got to store this message, however, in a variable that we can manipulate before we pass that back to the pointer as a new value. I think that's what we need to do. So we could say temp message equals, and we can take the reference. Uh, I don't know if this will work, but I'm just gonna try it. And this might be wrong. So we're gonna do star message, and then let's just do a console or print to test this out. Doing it the right way is more important than just hacking my way along. So fmt dot, I like to do a console log print f, and I'll say temp message, and then I'll say I'll just put message before. And then what I'm going to do is I'm going to manipulate temp message and see if that changes what message is like right here. So temp message equals 3. I don't know. It doesn't really matter. Um, and then fmt.printf Pringle typo. Okay, so so tip MSG, like the flavor, and then we'll go tip MSG. Okay, let's see what this gives us. Oh, I need here message and temp message. Empty argument list 13. Oh, my bad. Bring imported but not used. Sure. Let's just comment that out. See now, if the GoLang playground thing had a little thing like this instead of this, whatever this is supposed to be, we would really be doing something. Okay, let's run this. Undefined temp message. Oh, we got to do this. Cannot use 3. Okay, sure. Taco. Taco cat. Oh gosh, this is very aggressive language. Okay, let's put some line breaks here and also put a line break here. Gotta break it down. I never went back and checked the chat thing. I'm sorry. I done forgot about that. My bad. I know the chat gets more people in here. I got really, really deep into it this time. Okay. So let's check here. We changed the temp message. Let's put a line break here. I don't like to struggle too much when I read. Make it easy on me. So at the beginning, messages as it comes in, it's just an address. Then temp message. Okay, so what this is showing me here, let me just check one more thing. Let me put this down here. And then I'll say what I think is happening. Okay, so what this is telling me here is like we can when we do this here, this is making a copy of the data, and this copy that exists in temp message, it exists independently of the original incoming pointer data. So that's going to be very useful for what we're trying to do here. So I'm gonna comment this out for now. I'm not gonna delete it. Don't delete your comments until, or don't delete your consoles until you don't need them anymore. Take it from a pro. Okay. So now what we can do is we can say temp message dot replace all, and then we can let's see what replace all does. What is S? Oh, okay. So S and then the old thing and the new thing. Okay, so we'll do temp message and we'll say fub, and then we'll say star 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 star. Can you do pointers to pointers to pointers to pointers to pointers? Like, could you put this in front of something? Oh gosh, you see how these tangents in my brain and the amusement and the, oh gosh, everything's a squirrel. I guess that means I like it. Okay, so let's see what happens. Let's go ahead and put another log here. We'll just say fmt.printf, and then we'll say current temp message, just to keep track of what we're doing. I always tell my students, when you're coding, like, just don't assume, just walk through it step by step. Do that and you'll be fine in the long run. Um, oh wait, I didn't even see the usage. My bad. Strings. My bad. I gotta do strings dot replace all. I'm so used to doing things the JavaScript way, where everything is an object and therefore has a method that somewhere lives within it. Undefined strings. Okay, let's bring it back. Uh, no formatting directives. Sure. See, Go just kind of tells you, do this, do this. It gives you a whole checklist. Oh, because Taco Cat is here. That's why. That's the issue. Taco Cat's always. I have a Taco Cat actually. I should bring him. It's a little toy. Um, we should see it before and after. That's a good thing to do. So before and after. Run. Okay. And we'll do this. So, oh, we got to put a line break in here. Um, I don't think it's working. It should use the function to replace all the instances of the following words in the input message. Um, well, mm, mm-hmm. Uh, let's try it with shiz. I feel like the uncool kids said the word shiz. You know what I mean? The cool kids just said it. I wasn't a cool kid, by the way. Uh, replace all. Um, I'm not sure what's going on here. Okay, so we're. I, let me. let me just do one thing. I'm gonna try to do this without using a temp because that might be an assumption that I don't need to make. Um, and let's just do this with the message. And we'll do the pointer to the message. That's the value. And we'll just get rid of this for a second. Where's the shiz one? It's not working. Okay, so I'm gonna go ahead and use my uh what's this called? The baked salmon. I'm gonna go ahead and ask a question. I'm just gonna put this in there. This is what I would do in Claude, but I'm gonna go ahead and just use the salmon because I'm gonna continue to build up a catalog of salmon, and I don't need to do that. Yes. So I see you're trying to debug your code. Let me explain what's happening here. Can't modify the original string. It returns a new string. Oh, okay. So I need to do something like this. Temp string equals, and then I can put temp string here, and I can put the pointer to message here. So this should be what I want. I think, and I have to do initialization here and make sure I get the typos corrected. And then this needs to be um, message. Okay. Yeah, that worked. Okay, so I just got to do this for all of them. So the first one is going to be, was it Fub? What was the last one? Which is 5 stars. Like a 5-star witch, like that one song that Nicki Minaj was on back in like 2008. Is that what we're referring to? I'm a barb, by the way, just so y'all know. Kind of, like a little bit, like a semi-barb. Enough. Okay, so and the last one here is witch, and then we'll just put that. So we can't do this with the same variable. But we can do this. And then let's just make sure all these are. Oh, we can't daisy chain this. But it was working when I did the first one, right? Am I tripping? Am I tripping? Yeah. I feel like removing the words, by the way, makes the cuss word seem worse. You know what I'm saying? Like we're removing these fake cuss words, but I think we're making it worse. We're, we're the problem. I'm the problem. It's me. Okay. Okay. So it is working when we do each of these. So how do we fix this? Um, we can make tip string one, tip string two, and then we'll put. Oh, I see what's happening. I see what's happening. So I'm doing replace all on message. So it's just not going to work because it's going to keep reusing the same thing. So we can put tip string here, and we'll put tip string here. So we got to use the copy that was made. Okay, so that is working now. So the last thing we have to do is replace it in memory. Memoir is message is equal to the pointer to temp string. Oh, we should initialize this as a so var temp string, and then we'll say pointer string, and then we'll Okay, equals, and then whenever we're using it here, we have to make sure we use the pointer here and here. I think that's what we're supposed to do. Oh, my bad, my bad, my bad. So maybe I can just do it like this. Oh my goodness, that made it worse. Um, let's just do it separately. So we're gonna make a nil pointer to temp string. So temp bar temp string star string. And now we can do this, and we'll say that this pointer's value. Let's just do one of these at a time. Whoops, one at a time. I am getting tired. Non-name temp string on left side. So it is already a pointer. So do we do this? Oh, so do we just not need it without the star? Cannot use. Okay. So if we wrote to memory, or if we replaced the value every, if we changed and then we went to the message. Ah, man. Maybe I'm trying to do this in a procedural way that just doesn't make sense. Oh, I think I know what I need to do. Um, maybe I need to do this. Nope, never mind. Um, okay, I'm gonna ask for some more help. Yeah, I'm just gonna do this. See what it tells me. I don't know if it can. I don't know if it knows what's going on in here. Creates a pointer to a string, but you want to work with the value itself. Okay, yes, that's true. Oh, okay. I'm gonna not read all of that, and then I'm gonna try it because I want my brain to work. I want to do the work with my brain. So I do that, and then replace all in temp string. Let's get rid of this assignment part. Let's just do focus on this right now. Okay, so that works, and this works, and this will not work again. Okay, now all we have to do is take temp string, and yeah, so this should work. Why didn't this work before? Can I use temp string? So we got to do this. Um, how do I reassign? Um, I think this is the line here that be. Oh, it worked. Did it work? No. Damn. Ah, what a disappointment. Okay, so we can console we can do a print here for. Oh, we missing one. Maybe that was it. Okay, it wasn't. Okay, so let's go ahead and copy this, and we'll just put message down here. Open message. Ugh, I can't wait to be done so I go to sleep. I'm tired. I found several other YouTubers that are doing similar like little grind videos, and it's like a nice little vibe. I dig it. I definitely dig it. I'm not the only one here is doing all of this. So, okay, so we can use the pointer here. I thought I had an error in trying to do that earlier. Okay, for some reason I thought I tried. Didn't I try something like this? Maybe well, obviously I did it wrong. But I feel like I tried something like this and I thought I saw an error about not using the dereference operator in reassignment. And maybe I was avoiding it because of a misunderstanding. I think that's what happened. Either way, let's go ahead and what should I do? How far am I into this? I'm only on number two. Oh my goodness. Okay, so ooh, okay. I'm not gonna use any XP potions, but what does this say? Oh, I earned the chest? Okay, well, you know what I'm saying? Doing big things. Let's get it. Oh, I got two gems and another big salmon. That's fine. Yeah, I have never hated salmon so much. But also in real life I actually love salmon, so can't be too mad. Okay, so we got 360 points there. Oh, we got 10% or 10 extra XP for a daily streak. That's nice. That's nice. We got halfway. Okay, so I definitely need to speed it up. I will admit that tonight I'm a little tired, very tired. Let me just tell you about my day. It happened. Okay, so that's good. Thanks. My dog had a rough day today. Oh my gosh. Oh, the poop. The poop. Ugh. So gross. That was my day basically. So I'm tired because it took a lot of energy. I had to exercise him, clean up everything, and then I was like, you know what? Let me just go here. I'm gonna do some coding. It's gonna make my brain feel real good. It's gonna give me some gratification. And I'm glad I did it. We got through it. You know, we did what we had to do. And also, let me just say that this thing that we did with all of this here and this whatnot business and this thing, I'm coming back to this. That was all great. Okay. The point of all of this for me was to have fun and learn. And maybe I go on my little tangents, but you know what? I'm allowed to do that. I'm not at work. This is my time, my channel, do what I want. And this was great. I learned a lot. So, anyways, I want to thank you for coming by. As usual, I always appreciate Showtime, energy, and attention. Let's do one more thing. I'm gonna embarrass myself, but I really want to see why primitive.com didn't work. Because I feel like I've had intermittent failures with trying to get this thing to work. So I don't know if it's like www dot. I need to really debug this. Um, because I feel like sometimes this works and sometimes it doesn't. Ooh, I'm so embarrassed. I am not good at this kind of thing, like DNS, domain names, and all that. Is it because it's a I don't want to go to HTTP. Uh, let's just do primitive.com. That's all I want. Ah, the stress. Is there a way to guilt my browser into like doing what I want it to do, like emotionally? Um, it doesn't care. Primitive. Ah, okay. I feel like I'm getting different results for how this is working based on if it's my Chrome browser or my Brave browser or the Safari on my phone. So maybe that means I need to look into something. Okay, I got work to do. I have a whiteboard where I keep track of all this. I'll deal with it later on. But if you want to know how to see my stuff, for now, what you can do is you can go to my link tree right here. Check out my link tree and have yourself a good old time. And take the survey while you're there, because the survey will help make this channel a better place. Well, it's going to be a better place regardless, but this will help me do it in a way that actually serves the interest that you may have in coming over here, okay? So without further ado, I'm going to go ahead and let you go. I'm going to go ahead and get you off the phone so I can go ahead and mind my business. You go mind your business too, okay? And I'll see you here again next time, probably tomorrow. But if you go anywhere, don't go too far, and make your way back to the wolf pack. Deuces.